So make sure that you watch your video in your notes about how to calculate lag time with the Bray way is what it's called on there. I'm going to show you quickly how to calculate lag time, but then I'm also going to show you how to find the distance to the epicenter. So the first thing is we are going to do our S wave minus our P wave. We always have our bigger number on top. So for example, I have an S wave that arrives at 21:29:00, and my P wave arrives at 21:21:20. Now with the Bray method, we're going to look at the seconds first, and we find the difference, and that is a negative 20 seconds. And then here, 29 minus 21 is 8 minutes. So to find the difference here, we're going to subtract 20 seconds from 8 minutes, and you get 7 minutes and 40 seconds. Always double check your work. 40 plus 20 equals 60. And that'll give you your 8 minutes there. Okay? So if you always need to double check, there it is. So now I have my lag time. Your lag time. So now what you're going to do, now that you have this lag time, you're going to use page 11 in your ESRT. And you want to shade in between the S and the P wave. I shaded it in green. That represents your lag time. And it's going to help you find your distance to the epicenter. So let's take a look at how this is set up. On the y-axis, we have our travel time. And each one of these blocks is representing 20 seconds. On the bottom here, you have your distance, and each one of these blocks is representing 200 kilometers. Now this is in scientific notation, so you are going to have to take it out of scientific notation. So for example, 1 is going to be 1,000. So this block here is 1,200, 1,400, 1,600, 1,800, 2,000. All right, so our lag time that we calculated, let me just move the camera a little bit closer here, was 7 minutes and 40 seconds. And I'm actually going to zoom in so you can see just a little bit better. Camera is So you're going to have Scrappy here. You're going to line Scrappy up along the y-axis. Now, what I do is I actually pull it off. I'm not going to line it up directly with the y-axis because I want to be able to see the 20-second blocks. So I lined it up. We're going to make a mark at 0. And we're going to make a mark at 7 minutes and 40 seconds. Because that was the lag time that we calculated. So this first is 7 minutes and 20 seconds, 7 minutes and 40 seconds. So this represents the difference in arrival time between the P and the S wave. So now what we're going to do is we are going to line each one of these marks up with the P and S wave curves so that we are able to find the distance. So I always start by going on the P wave here. So as you see, I've lined up my mark on the P wave, but my S wave doesn't fit. So now I'm going to start working my way down the chart. So if you take a look at this, the S wave's kind of a little bit above that line. So I'm going to move it up the chart just a little bit. And there it is. My P wave hits this mark, my S wave hits this mark. So now you're going to follow that down to find your distance. So here, you're going to follow it down, and it's one box after. So that's 6,200. So the distance here is 6,200 kilometers. So to find the distance to the epicenter, the first thing you must do is find your lag time, or the difference between the P and the S wave. And then you're going to use page 11 in your ESRT and Scrappy. You'll make a mark at 0, a mark at whatever the time was that you found, and you're going to slide until each one of these marks, the bottom one hitting the P wave, top one hitting the S wave curve on your chart here, and then follow that down to find your epicenter distance.